All right, welcome to 5-1, Solving Systems of Quadratics Graphically. And really, the overall title of this should be Nonlinear Systems, but we are going to do a focus on quadratics. So in order to do that, we also need to review how to graph quadratics in their various forms. On the screen right now, you see two parabolas, so one downward facing, one upward facing, and then they have points of intersection here and here. And that's what we're really finding when we solve a system, is we're finding those 2 points of intersections. So on this one, we have a solution at -2, -1, and a solution at -3, -4, +3. Sorry, it's early and I have a cold. So we're looking for both the x and y values, points of intersection. So that's what we're working with today. Let me jump back here. Have 3 different forms. We have the graphing form. I don't know what just happened there. Which is also known as Vertex form. We have the standard form and the factored form. So the graphing form, that is our y = a times x minus h squared plus k. That is where hk is our vertex. I don't know why my pencil is not working well today. And a is our stretch vector. So that determines how much we're going up. That's dying. Anyway, standard form is our y = a x squared plus bx plus c. That's when everything's been multiplied out and simplified. Then factored form, that's our root form. That's x minus √1 times x minus √2. Each of those has its own merits and its own advantages. Some of them take more work to graph than others, so we're going to go over those 3 different ways of looking at that today. Quadratics, however, first off, vertex form, that's going to be your easiest one to graph. Because of that form we had, what is going on? Y = a times x minus h squared plus k. What you're really looking at is what is in the h and k position, and how does a change that. So if we have x plus 3 here, and our normal form is x minus h, that means we had to have a double negative here. So this ended up having to be negative x minus -3 in order to make that a +3. So our hk, our vertex, is the point -3, 4. So I'm going to graph that, -3, +4. And the negative out in front, what that does to the whole thing is it takes the parabola and it makes it open down. So this is going to open down, right 1, down 1. And then it's going to be 3, then 5, so on and so forth. So out 1 and down 1, out 1 and down 3, out 1 and down 5. So that's my parabola. That's my graph for that one. In each of these cases, it's going to be necessary to find the vertex no matter what you're doing. It's just easier to do that with the vertex form. The y-intercept is what y equals when x = 0, so we just plug in 0. It's not totally necessary to find with this form, but it's a good thing to know how to do. So we've got -3 squared plus 4. So negative stays there after we square 3, so -9 plus 4 gives us a -5, which we also see over here on the graph. So 0, -5. So that is graphing from the vertex form. From standard form, the equation itself isn't going to show us the vertex without doing some work. So there's two ways we can go about that. I'll go ahead and start with my y-intercept. Plug in 0 squared minus 2 times 0 minus 3. So that gives us -3, 0, -3 for my y-intercept. So I'll put that on the graph. The way that we can find the vertex, there's two different ways. One is -b/2a to find our x value for our vertex. I'm going to stretch this out a little bit and then zoom back in so I have the space. Sorry, a little crooked. So this goes with the a, b, and c. A is 1 in this equation, b is -2, and c is -3. So x equals -2 over 2 from the formula, and then times a, which is 1. So a double -2 right here gives us a +2. 2 times 1 gives us 2, and then 2 divided by 2 is just 1. That gives us our x value. Once we have the x value, we have to find y. So we plug in the 1 from our x that we got into all of our x's into our equation. So 1 squared minus 2 times 1 minus 3. And normally I would go down to show this work, but since I'm out of space, I'm going to go 1 minus 2 minus 3, which is -4. Let's zoom back out. So that means my vertex is 1, -4. And I can go ahead and graph that point as well. Right there, I think. Yeah. The other way to do this is by completing the square. I'm not going to get into huge depth about how to do that. If I have y equals x squared minus 2x minus 3, take half of my -2, so x minus 1, so that -1 came from half of -2, squared. If I have that squared, I need the third term here to be the -1 squared, which is just a +1. To get from -3 to +1, I have to add 4. But it's not mathematically legal to just add 4. I also have to then subtract it. What is up with my thing? So what I have here is I'm adding 0 with the plus, more, and minus 4. So that's a legal move to make. And what I have here is equivalent to the x minus 1 squared. And I just drop down this -4, and now I'm in vertex form with an HK of 1, -4. So once again, my vertex is 1, -4. I apologize for all the glitches. Something's going on with my Apple Pencil, and I don't know what it is. Factored form, I wouldn't put it in factored form if you're in standard form, because you're going to make some extra work for yourself. But I'll show you how anyway. Start with your first term, x term, -3. Multiply those to get your top, -3x squared. Add them to get your bottom, not add them, but your middle term, -2x is your bottom term. Only factors of 1 and 3, of 3 are 1 and 3. The 3 has to be negative since I have a -2, so -3x and 1x go in the remaining boxes. And then we factor out greatest common factors from each row and column. So when I do that, I have an x here. X times x is x squared, x times -3, x times 1. And then 1 times -3 is -3. So my factored form x minus 3 times x plus 1, which means I have x-intercepts at 3 and -1, which I can also put on the graph. Those are not necessary to find. You can build your parabola based on that negative b over 2a, or completing the square. Factored form, I would only use this if you're already in factored form, and then I'm going to go to the next page, how to graph from factored form. So when you're in factored form, x plus 5, x minus 3, so this is a new one. We know our x-intercepts from that. They're whatever make these individual factors equal 0. So if I've got x plus 5 equals 0, then I have an intercept or a root at -5. X minus 3 equals 0, add 3 to both sides, so x equals 3, that's my other root. I can graph those. Whoops, that's positive 5, I don't want it there. So -5 and positive 3. The parabola is a symmetric shape, and so your vertex is going to be halfway between your x-intercepts. So what you can do is take your x-intercepts, -5 and 3, and average them. So -5 plus 3, and we divide by 2 because there's two numbers there. So that's -2 over 2. So your x value equals -1. And like any other thing, if you have one of your values, if you have your x value, you plug it in to get your y value. So y equals -1 plus 5 and -1 minus 3. So 4 times -4, which is, I don't need parentheses there, -16. So our vertex is 1, -16. No, -1, -16, sorry. And I can build the rest of my parabola with the 1, 3, 5 pattern around that. And when you're solving by graphing, which is what we're doing overall in this unit, is, or in this section, sorry, you really need to graph as carefully as you can, because if you're finding points of intersection from the graph, you're not going to find those very easily if you don't have it graphed well. On the y-intercept, again, we don't have to do this part, but plug in 0 for your x's, so 0 plus 5, 0 minus 3 is 5 times -3, which is -15, which we already see on the graph right there. So moving on, now we need to actually use that for the purpose of what we're actually doing. So this is one of the practice problems. If I have -x plus 8, so that first equation right there, this can be looked at as standard form or factored form, or sorry, not factored form, standard form or vertex form. If you look at it in terms of vertex form, y equals a, for heaven's sake, times x minus h squared plus k. This can be written as y equals -x minus 0, because I have nothing in the parentheses, and then plus 8. What is wrong with my thing? Ugh, sorry. So then I have a vertex of 0, 8. So I can go up to the point 0, 8 and make my vertex. Because of that negative, this is going to be opening down. All right, so there is my parabola. My next part of this, -2x plus 5, that is not a parabola. That's just a line, and that's in that y equals mx plus b, with my slope and y-intercept. So y-intercept of 5. So I'm going to go up to 5 and make a point, and a slope of -2, which means I'm going to go down 2 and over 1 and make my next point. I'm going to erase those two lines so it doesn't get too confusing. Down 2 and over 1, down 2 and over 1, down 2 and over 1. If you go backwards, I'm going to go back 1 and up 2 and fill in. And then I have my line. Not very straight, but it gets to the point of having my points of intersection there and there. So my solution to this system is the points -1, 7 and 3, -1. One more example and then we're done. These are both in vertex form. So the first one I'm going to do in red, -x-4 squared. That has an HK of 40, so it's got a vertex of 40. Because of that negative, that's going to be opening down. And then I make my parabola. Make sure you don't just put your points in, that you also draw your parabola. The next one is also, Jesus H, what is going on? Also in vertex form. This one has an HK of 4, -2. This one opens up because there is no negative out front. So 4, -2, out 1 and up 1, out 1, up 3, out 1, up 5. And I draw that parabola. So you have to pay close attention. You're not always going to be graphing parabolas. And then I have my 2 points of intersection at 5, -1 and 3, -1. And those are my solutions to that particular system. So that is graphing to solve in a nutshell. We have previously done the systems of linear equations. Now we've done graphing by, or graphing to solve quadratic systems, and then next we're going to do quadratic systems algebraically in 5-2. Thanks so much.